First we will start by setting the throttle range wizard. Do this by clicking the wizard, set throttle range wizard. Do this with the ignition on, engine not running. Release the throttle all the way and press the minimum button, and then depress the throttle and press the maximum button. This will set up your ranges. Click close, and you can see in the display that you're currently at 2.4 or 2.5%. Next, look at the idle options table. You will want to set your idle on and idle off parameters to a value slightly higher than what your throttle position is while your throttle is at rest. This will tell your ECU that anytime the throttle is less than 3.1%, it needs to idle, and when it's over 3.1%, it needs to turn the idle functions off. Next, I'll go over some of the idle options. First two on the list is idle feedback above and below RPM. This tells the ECU that when the engine speed is above 400 and below 1800, it's in the idle region. You can change the 1800 to an RPM that is slightly higher than your highest idle you will see upon cold engine starts. We already went over the next two, but I will just mention it again that you should set these two percentages slightly higher than your throttle percentage at resting position. Next is idle feedback minimum and maximum. This value represents how much feedback you're allowing your idle air control motor to have. Right now I'm allowing the idle motor to subtract 5.1% and add up to 9% in order to maintain your target idle speed. These numbers are fairly small and you can make them larger, especially if your settings are way off. Idle feedback deadbands are two important settings that tell your idle motor when it's allowed to adjust your idle. Current settings will tell the ECU that when the engine speed goes 75 RPM under or over your set target idle, it's allowed to adjust it to try and fix the problem. On a big cammed car, you can go with 75 or 100 because your idle will not be that precise and stable. Unmodified engines have a much smoother idle, and you can set the deadbands to plus or minus 50. Idle P-gain is a proportional and air-dependent idle feedback. It's used to quickly increase the idle position to prevent the engine from stalling. Older firmware does not have this feature, but it makes a big difference in idle. I will go ahead and show you the effects of changing this value. You can take a look at how it affects the idle speed after revving up. Pay close attention to the engine speed and how much it oscillates with different P-gain values. You can play with different settings, but normally you want to use the highest value without running into oscillations. Here I increase the P-gain value way up there and rev the engine, and you can see that as the RPMs come back down, they'll oscillate and go over the target and then back under, back over, back under. If you make this number smaller, it'll prevent that from happening. Idle feedback rate is in milliseconds, and it plays an effect on how fast the ECU adjusts the idle motor to correct idle target errors. If you make this too small of a number, you can run into idle hunting because it's making changes so fast. Tune this until you get a nice steady idle. The next three parameters are used for pulse width type idle air control. You can set the maximum duty percent, the frequency at which to drive the motor, and the output. The Super being tuned as a factory stepper type motor, so these settings play no effect on the idle. We're going to go ahead and start tuning the idle. First, let's set the deadbands to plus and minus 3000. What this does is tell the ECU to only correct the idle if it's off by 3000. In other words, never to correct the idle. This will allow us to find the ideal motor position to get whatever RPM we want without the idle feedback correcting our motor position. Also, go to your ignition versus idle RPM table and zero that all out. You can do this by selecting the entire table, or just press Ctrl and A, then press S to set value and set the value to 0. Ignition plays a big role in idle, and we don't want that messing with our tune right now. Also, what we will check is that we have a smooth transition in the ignition map from the idle region to the cruise region. If we have a very drastic change in ignition, it will tend to hunt when it reaches the higher ignition values. Since more ignition advance will raise the idle, it will want to shoot up. Most cars, from my experiences, idle with an ignition advance 10 to 18 degrees. Make sure that your idle region has a nice flat area with ignition values being the same. Let's take a quick look at the RPM offset versus TPS table. This table is crucial in some cars for stop-and-go traffic. On some tunes and cars, you can just zero this table out and still have good drivability and no stalling. This table raises the RPM with the smallest amount of throttle opening, so that you have enough engine speed to get the car going. Make sure that your resting throttle position does not raise the RPM in this table, otherwise your target idle speed will be different than what you set it in the next table. Now we will start tuning the idle percent versus target table. Position them on your screen so you can see the idle channels as well as the two tables I'm enlarging. If you don't have an idle channel on your list that you would like to see, all you need to do is right-click inside the table and insert a channel from the list that will come up. Same thing for the tables. Right-click in a white section where there is no table and you can add a 3D table, 2D table, options table, etc. Start off by selecting the entire idle target base table, setting the values all the same to a target RPM you want to start tuning. I started with the target base table set to 1300 RPM. Start by moving the idle percent versus target table up and down to get your RPM to match the idle target you have set. As you can see, the idle error duty and the idle learned values don't move much or at all because you have the deadband set to plus or minus 3000, so the idle correction is not being used. The idle position shows the percentage that the idle motor is open, and these values do move as you move the settings in the idle percent versus target table up and down. After your engine speed matches the idle target you have set, you are done tuning that area. Next, go ahead and set your idle target base table to another RPM and tune that area until that engine speed matches the target you have set. As you adjust your engine speed, don't forget to watch the air-fuel ratios and your ignition timing. If your car has air conditioning, this is where you can make sure that your car idles good even after turning the AC on. AC idle load count percentage will raise the idle RPM a percentage based on this value. AC on delay time is in seconds and will raise the engine idle speed 0.38 seconds prior to the AC compressor actually kicking on. There's also an option that's not shown that you can add to your options that will allow you to select a minimum RPM for AC to work. This way, when you're starting your engine or your car begins to stall, the AC compressor won't be on. The last thing we'll look at is injector advance. This table determines in degrees from the first crank tooth after synchronization when the injectors will be sprayed. On most cars you will not gain or lose anything by messing with this table, but for my fairly aggressive cams car it does seem to make a minor difference to my idle. You can try tuning the part of this table that your car idles in to see if it makes any difference for your car's idle. On some cars it might also affect the throttle response. Blip your throttle to see if it makes any difference. After you're all done tuning your idle percent versus target table, make sure you do not forget to set your deadbands back to plus or minus 50 or whatever you feel comfortable with. I will set mine to 75 and I will show you another method you can use to tuning your idle. Once your deadbands are set correctly, you will notice that your idle learned value and idle error duty will start working to keep a steady idle. If I raise the idle percent versus target table in the 900 RPM region, you can see that the idle learned value will get smaller. I try to make this number right around 0. This means that your table is spot on for that RPM. Set the idle target base map to another RPM and tune that area as well. I went ahead and set mine at 1200 and looked at the idle learned value to make sure it's close to 0. If the idle learned value is not where you want it to be, just raise or lower your idle percent table in that RPM region to get the learned value close to 0 or what you feel comfortable with. You want your idle percent versus target table to be somewhat smooth without big dips or spikes. A fast way to make this table is to tune the 900 RPM idle, then tune the 1400 RPM idle, and interpolate the region in between by highlighting and pressing H. After you get your idle percent versus target table tuned, we can go back and set up the ignition versus idle RPM table. Some cars it's not necessary, but for my car it helps smooth out my idle. As you advance ignition it will raise the idle, and if you retard ignition it will drop it. So therefore I like to set mine up like this. I add 10 degrees if my idle RPM drops 75 RPM, and subtract 10 degrees if it goes higher than 75, and interpolate in between by highlighting and pressing H. Another table I'll go over is the RPM offset versus start table. This sets a programmable duration for higher idle when you start your engine. I have mine set to idle 200 RPM higher for 8 seconds, then drop back down to normal idle speed by 10 seconds after I start the engine. This helps an engine keep running after it's started instead of stalling right away. Once you're all done tuning, you need to set up your idle target base. This table determines at what engine speed to idle depending on the coolant temperature. You need to have the engine idle slightly higher when it's cold to warm it up quicker and to prevent stalling, and then slowly drop the idle as the engine coolant increases.